Previously, we talked about grep as a command that allows you to search for specific text or patterns of text inside a file. Grep is great for that purpose, but is generally limited to that specific task. Often, you'll want to not just find patterns of text in a file, but make edits to the file based on those patterns. This can be achieved with a separate command, sed, which we'll cover here. If you want to follow along using the example file I'll use, it's available from the link pasted in the comment pinned to this video. And it's just a renamed version of the FASTA file we used in the previous grep and regular expression videos. Sed actually provides several different options of ways to make edits to a file, and I'll refer to these as functions within sed going forward. Before we address any specific functions though, let's first talk about the general structure of a sed command, which has several components, some of which are optional. The first component, of course, is the sed command itself. Next, I'm going to jump all the way to the end for the next component we'll consider, and then come back to fill in the middle, which really contains the meat of the sed expression. One thing to keep in mind with sed is that unless you use the -i argument to explicitly tell it otherwise, no changes will ever be applied to the input file. The default for sed is to print its output, which is the edited version of the input, to the screen, and not modify the original file in any way. Printing edits to the screen usually isn't all that useful, so most of your sed commands will end with a redirection expression, often the greater than symbol that I have here, paired with the name of a new file the output will be written to. This part isn't really a component of the sed command per se, but just a general redirection of output that can be used with any commands at command line. Working backwards from there, and getting back to the specific components of the sed expression itself, you'll always need to point sed to some input text, or in other words, the text you want to make edits to. It's possible to use the pipe operator to use output from previous commands as input for sed, but we'll focus here on the more traditional approach where input comes from a file. That file name will be the last part of the sed expression, again, keeping in mind that the redirection isn't technically part of the sed expression. So we start with sed, and we generally end with a file name that provides the input, the greater than symbol to redirect sed's output, and then the name of a new file to write the output to. Now we'll work on filling in the middle. This is the part that specifies what edits you want sed to make to the input text. A generic structure for this section of a sed command is first, possibly some options that are associated with sed itself, and then an expression that consists of up to 3 items: an address, which is optional, a required function, and finally, possibly some additional options that are associated with that specific sed function. Let's start by focusing in on the function part, since that's the only required portion. There are quite a few sed functions to choose from, but in practice, there are a limited number you're likely to use. Each function is represented by a single lowercase letter, and some have additional syntax that they require. Let's take a look first at a simple function that doesn't have any additional syntax. A lowercase d represents the delete function. So a very simple but complete sed command would be sed d sedpractice.fa greater than symbol sedout.text. While not always absolutely necessary, it's a good idea to get in the habit of wrapping the function, here the d for delete, in quotes. You'll usually want single quotes, but occasionally might need double quotes. That topic is addressed in the previous video on grep. When run, this command reads through the sedpractice.fa file one line at a time, deletes each line it comes to, and prints the output to the file sedout.text, which, since all the lines are deleted, shouldn't include any output. Indeed, if we view the out file with less, there's nothing in it. So, just to review in the context of the general structure of sed commands that we just talked about, this sed command had the 3 components that are required: the sed command itself, the function within sed that will be applied, and the input file it will be applied to. We also redirected the output to a new file, which is a very common thing to do with sed. Now let's add an address, which is one of those optional parts. The address comes directly before the function and defines specific lines in the file that the function will be applied to. A line count on the input file tells us it contains 200 lines. If we specify 11 through 200 in the address, note that a range of line numbers is defined with a comma. The delete command is applied to lines 11 to 200. Since the first 10 lines aren't deleted, they're printed to the out file, as we see here by viewing it with less. A second way we can specify an address, which again defines a subset of lines in the input file to apply a sed function to, is to use a regular expression. Before we try this, remember from the video that introduced regular expressions that there are different types of regular expressions. Sed offers two: basic regular expressions, which is the default, and extended regular expressions. In this next example, we'll stick with the default, since in this specific case, both will behave in the same way. Let's also make sure we're clear about what's in the file we are editing. Previewing it, we see a typical FASTA formatted file with DNA sequence information. Each DNA sequence is represented by two lines: a name or description line, which always starts with the greater than symbol, followed by the corresponding sequence. Imagine we wanted to delete all of the name or description lines and just keep the sequences. We can use a regular expression in the address to apply the delete function to lines that contain the greater than symbol. The regular expression is bound by forward slashes, which is notation that's pretty widely used to define boundaries of a search pattern. A line count on the out file shows that 100 lines were printed. This is what we expect: every other line from the input file. And previewing the out file, we see that indeed it was the sequence lines that were printed. Now, let's explore the behavior of regular expressions in sed a bit more by taking a different approach to achieve the same result. Another characteristic of the name lines in this FASTA file is that they all contain a date representing when the sample was collected. If you watched the video on using regular expressions, you might remember that the format of these dates is not consistent, with some recorded as year, month, day, and some as month, day, year, as we can see in the two examples highlighted here. We'll come back to that issue shortly, but for now, let's just focus on the 4-digit year that's in all of them, and try using that pattern as a regular expression to match those name lines. I'll use square brackets 0-9, followed by a 4 in curly brackets, to try to match lines containing any 4 digits that occur in sequence. The goal, again, is to delete all of the name lines and print the 100 sequence lines to the out file. However, when I run this and check the number of lines in the out file, all 200 lines were printed, so none were deleted. This is because the curly bracket quantifier is supported in POSIX extended regular expressions, but not in basic regular expressions. This is a good place to think back to the components of a sed command and introduce our first option to sed. Adding the -e argument, or sometimes -r depending on your platform, between the sed command itself and the expression that defines the function, in this case the delete function, causes sed to interpret the regular expression as an extended regular expression and gives us the result we were going for: the 100 sequence lines printed to the file, which we can see both with a line count on the file and a preview of the out file's contents. For the remainder of this video, we'll take a look at a second function available in sed, the substitute function. I mentioned earlier that there are a number of functions available within sed, but in practice, you'll likely only end up using just a few. We just dealt with the delete function, which you'll have the use for on occasion, but you'll probably find that the great majority of your use of sed will be with the substitute function, so it's worth getting to know it well. Analogous to the lowercase d for the delete function, the substitute function is represented by the lowercase s. If we start to construct a sed substitute command following the pattern we used with the delete command, you can probably quickly see a problem. If you want to make substitutions in the file, or in other words, find and replace text, you need to define what text you want to find and what text you want to replace it with. This is different than defining an address, which specifies entire lines a function will be applied to. Instead, with substitute, we want to identify specific patterns of text within a line for replacement. For this reason, sed's substitute function has additional required notation. Specifically, the lowercase s that defines the substitute function has to be followed by two items, the text to find and the text to replace it with. These two items are typically delineated with 3 forward slashes. One before the search pattern, which will be interpreted as a regular expression, one between the search pattern and the replacement text, and one after the replacement text. Note I said that forward slashes are usually used as the delimiters. It turns out that you can use any character for these 3 delimiters. Whatever the first character is that immediately follows the S defining the substitute command is what will be interpreted as the delimiter. This can be useful to keep in mind, for example, if you're searching for a pattern of text that contains the forward slash. In that case, you might choose something else like a colon or the pipe as the delimiter to make the code a little easier to read and write. Like I said though, in most cases, it's common practice to stick with the forward slash. Let's try out a substitute command now. In each name line of the file, there are fields that are separated by a colon. Let's say we wanted to change the delimiter in each of those name lines from a colon to an underscore. We'll define the search pattern as a colon and the replacement as an underscore. Previewing the out file, we see this didn't work exactly like we expected. The first colon of each line was replaced like we wanted, but the others were left in. This default behavior can be modified with a G or global option to the substitute function. Going back to the general structure of a sed command, this represents the last component, options associated with a specific function within sed. Running it with a global option, we see the results we expected. All of the colons are replaced with underscores. Before we finish up with sed, let's look at one more example with the substitute function. This time, we'll do a search, capture, and replace that's equivalent to the one we did in the earlier video on using regular expressions. Like I mentioned earlier, the dates in the sequence names are formatted in 2 ways. Let's pick out all of the dates that are in the format month, day, year, and change them to year, month, day so that they're all consistent throughout the file. Like we saw in the previous video, we can use parentheses to capture text that matches a particular pattern and then retrieve that text to use as a replacement. Unlike in the previous video where we used the $sign to retrieve the saved text, sed uses the backslash to define the numbered variables. So here we're capturing 3 items within our search pattern: the 2-digit month, the 2-digit day, and the 4-digit year. And these get assigned to variables \1, \2, and \3 respectively. We can then arrange those variables in the order we want them in the replacement. Notice here that with the curly bracket quantifiers, we're again using meta characters only available in extended regular expressions. So I've included the -e argument. Viewing the output file, we can see the dates are now all formatted the way we want, in the order, year, month, day. To wrap up, sed is a great option for editing text files at command line. While it offers quite a bit of functionality, just getting comfortable with the 2 functions we covered here, delete and especially substitute, will not only cover the great majority of the times you'll use sed, but should also give you enough of an understanding of the general behavior of sed and the structure of its commands to allow you to look up and use any of the additional functions and related options you might find yourself needing.